Okay, for this note-taking, we're doing compound probability of independent or mutually exclusive events. So first, let's start with some vocabulary. Two events are independent if the occurrence of one event does not affect the likelihood of the other event occurring. Two events are dependent events if the occurrence of one event does affect the likelihood of the other. So looking at this problems right here, I get an odd number on a spinner and a red marble from a bag of marbles. A spinner is not going to affect the bag of marbles, so that is an independent event. Those are independent events. The next one says choose a class member for your study group, which means you have a class. Once you take one out, you can't choose them a second time, so that's going to affect your second choice. So these are dependent events. For independent events, the probability of both of them happening is the product of their probabilities. So what is the probability of rolling a number 3 on a cube and choosing a heart from a deck of cards? So you have two events happening. Event A, or the probability of A, is the probability of rolling a 3, which gives you 1 in 6, because there's one 3 on a number cube. Event B, or the probability of B being choosing a heart, let's just draw it. Choosing a heart is going to be 12 out of 52, because there are 52 hearts in a deck. There are 12 hearts in a deck of 52 cards. That simplifies to 1/4. So 1/4 of the cards are hearts. To find their probability of both of those things happening, I multiply their probabilities. So 1/6 times 1/4. Multiplying straight across gives me 1/24. So the probability of rolling a 3 and drawing a heart is 1 in 24, or 1/24. A desk drawer contains 5 red pens, 6 blue pens, 3 black pens, 24 silver paper clips, and 16 white paper clips. If you select a pen and a paper clip from the drawer without looking, what is the probability that you selected a blue pen and a white paper clip? So event A is selecting a pen, or selecting a blue pen, and event B is selecting a white paper clip. So the probability of a blue pen, well, that means I need to know the total number. So the total number of pens is 14, 5 and 6 and 3 is 14. So there's 14 pens, and there are 6 blue ones. So you have 6 in a 14 chance of getting a blue pen when you draw a pen. And then the probability of white, there are 40 paper clips, 24 and 16. So out of 40 paper clips, there are 16 white ones, which is equal to 2/5. This one simplifies to 3/7. The probability of both of those happening is the product of their probabilities separately. So I'm going to multiply those together to find it. So the probability of blue and white is 3/7 times 2/5, which is equal to 6/35. Okay, if two events are mutually exclusive, it means that they cannot occur at the same time. For mutually exclusive events, the probability of them both happening is 0, but the probability of either of them happening, which means one or the other, is the sum of their probabilities. So looking here at this example, I have 8 tiles, and the numbers are 3 through 10 in a bag. So I have 3, 4, 5, 6, 7, 8, 9, and 10 in the bag. and I want the probability of randomly choosing a tile that is both even and prime. So there are two events. Event A is that it's even, and event B is that they're prime. And when I look at this, my only even prime number is 2, and it's not in my list. So my probability of this happening, the P of A and B, is 0. They can't both happen in my sample space that I have. So, but then I look at the next part, and it says, what's the probability that it is, what's the probability that it is even or prime? And remember that or is the key. And they don't overlap, or they don't share any things in common, means there's a 0, but an or means I add them. So right here I have an or, I add their probabilities. So the probability of an even number. Well, even numbers up here are 4, 6, 8, and 10. There are 4 of them out of 8. So P of even is 4 out of 8. And then the probability of prime, well, the prime numbers up here are 3, 5, and 7. 9 is not prime. So the probability of prime is 3 out of 8. So to find the or, probability of A or B, I add these two probabilities together, so 4 eighths plus 3 eighths, which equals 7 eighths. Okay, so now I have two mutually exclusive events. It tells me that. So I'm following these procedures up here. So that means with an or, I'm looking at adding their probabilities. So both of these are or, so I'm going to add them together. So 1/3 plus 2 ninths, which equals 3 ninths plus 2 ninths, which equals 5 ninths. That's the probability of A or B. And down here I have 2/5, again mutually exclusive. I add the probabilities, and it's an or, so I add the probabilities. It's going to give me 14/35 plus 15/35, which gives me 29/35, which is the probability of A or B. So this is independent and mutually exclusive events, compound probabilities of those.